Hi, I'm Rob Crumley, Industry Account Manager for Precision Sensing here at Balluff. And I'd like to show you our lab automation demo. Let's start with here the microscope slides. Right? Sensing the clear glass edge of a microscope slide is very demanding. And there's a lot of factors involved, of course. Are they ground or cleaved? In this case, we have a couple of examples to show you here. We have a through beam precision LED right there, 1.8 millimeters in diameter. Detector over here on the other side, if you can see it. And the through beam approach is what we recommend, but we've also got over here a diffuse energetic sensor that is going to, on an angle, it's going to hit the microscope edge, and then it's going to be received right here. The detector is in the same package. It saves space, although we recommend the through beam for the most reliable application. Over here we have our Pipette Sensing and level type applications. We have, again, very precise through beam sensors, an emitter and a detector. We manufacture the LEDs ourselves, so we choose the wavelengths that we use to match the media that we're sensing. Multiples can be used for pipette presence, pipette low, pipette high. We also have back here some mini ultrasonic sensors. These have a focusing nose cone on the front to focus the light down to a very small pinpoint acoustic wave that goes down into the well and then bounces back up, and that is a quality check to ensure that the well fluids were dispensed into the well. And over here is a demonstration of the two principles that we usually use to do this precision sensing: refraction and absorption. In this case, we have a vial of water. Now, water being an aqueous solution has a very high absorption rate. So if we were to use infrared sensors here and put the water in place, the infrared is actually being absorbed by the water, and so less infrared light is ending up at the detector, and we're triggering on that with an output. With the refraction principle, you may be familiar with the stick in the water. Everybody's seen the stick in the water. And what's happening here is this is IPA, alcohol. And alcohol would not work with infrared, but with the red light, we get a bending of the red light. The red light bends away from the detector, and so the signal level drops, and we detect that. And how do we detect all that? Well, we detect that with our amplifiers. Our amplifiers have many features. We have premium amplifiers, we have economy amplifiers, but they're loaded with features. Threshold tracking, dynamic mode, window mode, 1-point, 2-point, automatic teach. All these features help us to set up the application to make it extremely reliable. If you'd like to learn more about the lab automation demo, visit us at balluff.com. Thank you.